Hello everyone, welcome back. Let us understand properties of logarithms by considering simple examples. Let us list out properties of logarithms which are useful to solve many numericals. The first one is logarithm of a to the base a is equals to 1. That means that when the base and the number are same, the logarithm value is going to be 1. Let's take one example. Logarithm of 3 to the base 3 is equals to 1. From the definition of logarithms, we know that in order to obtain this 3, we have to raise 3 to the power 1, right? So 3 will be equals to 3 to the power of 1. So that's the reason whenever the base and the number are same, its value is going to be 1, right? Let's look into the second property. As you know that in indices, we discussed any number to the power 0 is always equals to 1. From the transformations, we can say that 0 will be equals to logarithm of 1 to the base a. Right? So that's the reason logarithm of 1 to the base a is equals to 0 irrespective of its base value. If you consider example, logarithm of 1 to the base 100 also equals to 0. Right? Let's look into the third property. Logarithm of mn to the base a is equals to log m to the base a plus log n to the base a. That means that product of two numbers logarithm is equals to sum of their individual logarithms with the same base. So this is applicable when the bases are same, right? Let's take one example. It is logarithm of 1 into 2 into 3 to the base 10. So this we can write it as logarithm of 1 to the base 10 plus logarithm of 2 to the base 10 plus logarithm of 3 to the base 10, right? So here product we can represent in the form of addition when the bases are same. Let's take one more example. Log 6 plus log 5, we can write it as logarithm of 6 into 5, that is nothing but log 30, right? Let's look into the fourth property. Logarithm of m by n to the base a is equals to log m to the base a minus log n to the base a. That means that quotient of logarithm is equals to difference between their logarithms with the same base. So if it is given logarithm of example, it is log 32 by 5. So this we can write it as log 32 minus logarithm of 5. If the base is not mentioned, then we can consider it as base as 10. That is a common logarithm, common base which use generally, right? Let's look into the fifth property. The fifth property is logarithm of m to the power n to the base a is equals to n into log m to the base a. That means the number power is multiplied with the logarithm, right? So let us consider one example. If it is logarithm of 3 cube to the base 3. So here the power of the number is 3. According to this property, we can write it as multiplication to the logarithm. That is 3 into logarithm of 3 to the base 3. From the property 1, we know that any number with the same base value is 1. So we can write it as 3 into 1, that is nothing but 3, right? Let's look into the sixth one. Log m to the base a, we can also represent it as 1 by log a to the base m. That is, when we represent in the reciprocal form, we are exchanging number and base. Let's take one example. Logarithm of 10 to the base 3. This we can also represent it as 1 divided by logarithm of 3 to the base 10. Let us look into the seventh property. A power log m to the base a is equals to m. That is, here logarithm is indexed to the number a. A to the power of log m to the base a. If you observe here, the base is a and the number is m. So this we can also represent it as m power log a to the base a. It's nothing but m to the power log a to the base a value is 1. So its value is m. So this is called inverse logarithm property. Let's consider one example. If it is 9 log 3 to the base 9. At this time we can write it as 3 log 9 to the base 9. Its value is nothing but 3 power 1, that is equals to 3, right? Let's look into the 8th property. Logarithm of b to the base a is equals to log b by log a. So that means the logarithm with the base and number we can represent in terms of the division as log b by log a. Let's take one example. Logarithm of 5 to the base 3 we can represent it as log 5 divided by log 3, right? Based on this property, we can derive other two simple properties. The first one is logarithm of a to the base b into logarithm of b to the base a. What's going to be its value? As you know that from this we can write it as log a by log b into log b by log a, where we can cancel out log a, log a, log b and log b. So the resulting number is going to be 1, right? One more is if it is logarithm of a to the base b into logarithm of b to the base c. So this will be logarithm of a to the base c, right? From this property, this we can write it as log a by log b into log b by log c. Here we can cancel out log b and log b. So the resulting is log a by log c, or we can write it as logarithm of a to the base c, right? Now let us solve some questions based on the properties which we have discussed. Let us solve some numericals based on the properties which we have discussed. The first question is the value of logarithm of 0.004 to the base 0.02. In order to find out this value, let us represent 0.004 in terms of 0.02. So 0.004 is nothing but 0.02 whole square, right? If you take square of this number, the resulting number is this. So let us substitute that logarithm of 0.02 whole square to the base 0.02. From the properties of logarithm, this we can write it as 2 into logarithm of 0.02 to the base 0.02. From properties, this value is going to be 1. So its value is 2 into 1. It's nothing but 2. Let's write the properties which we have used over here. One is, the property which we have used is, one is logarithm of a to the power m to the base n. We can write it as m logarithm of a to the base n. And the second property is logarithm of a to the base a is equals to 1, right? Let's look into the second question. The value of logarithm of 10, log 2, log 9, log 81 with the base 9 is. In order to solve this question, let's start from log 81 to the base 9. As you know that 81 we can write it as 9 square. So let us substitute that first, logarithm of 9 square to the base 9. From this property, we can write it as 2 into logarithm of 9 to the base 10, right? Which implies logarithm of 10 log 2. Here it 2 into logarithm of 9 to the base 9. But as we know that this value is 1 from this property, so it will be logarithm of 10, and log 2 value, log 2 with the base 2 is also equals to 1. So I can write it as 1. Here it is 1. So which is nothing but logarithm of 1 to the base 10. But we know that logarithm 1 value is always 0, right? So the answer is 0, right? In next session, we'll solve some more questions based on properties of logarithms. Thank you for listening and have a good day.